Okay, ladies and gentlemen, this is Mr. Weideman, and I want to give you some quiz tips for our quiz on conic sections. All right, so conic section, that is our circles, our parabolas, our ellipses, and our hyperbolas. The key to success is what I'm going to show you in this first video. I've got some other videos where I'm going to work specific circle, parabola, ellipse, and hyperbola problems. But what I'm getting ready to show you in this video, I think is going to be your key to success. I am not really big into students memorizing information, but conic sections is nonlinear geometry. And geometry, you have to know relationships of dimensions. Conic sections is all relationship of dimensions. I'm going to show you what I mean here in just a sec. Now, what I'm getting ready to show you, I'm going to pick a hyperbola, no particular reason, but we need to be able to do it for every single one of the conic sections when I'm getting ready to demonstrate. All right, I'm going to just jump right into it. This is what you need to be able to do from memory for a hyperbola, an ellipse, and a parabola. Okay, hyperbola. Well, I can't count on it to be centered on the origin, but I know that its center dimensions are h, k. I know that I have what I call this, regardless of its orientation, I have this imaginary box that helps me set my asymptotes. All right, just for this purpose, I'm just going to call this one a horizontal. So I know that this is my transverse axis. And this guy right here is going to be my conjugate axis. This will be one of my vertices. This will be my other vertices. Here's what's critical. From the center point to my vertice, I have this dimension called A. From here to here, this dimension, half of my length of my conjugate axis, is called B. I have a foci here. I have a foci here. And his distance from the center point is this guy called C. C and A and B are related by Pythagorean. This is a horizontal orientation, so that means that my A is going to be the denominator, or actually my A squared is going to be the denominator of my X term. And my Y term is going to have B squared equal to 1. A does not have to be bigger. That's for ellipses. Okay, did that from memory. Now what am I going to do? Repeat. This time, I'm going to make my transverse axis vertical. My conjugate axis horizontal. There's my vertex, foci. This now becomes my distance A. This now becomes my distance B from here to here. From here to here still remains C. This relationship still holds true. So what's changed? My y minus k now has the a denominator. He's positive because I have a vertical orientation. He becomes negative, equal 1 for both horizontal and vertical orientations. I'm missing one last thing. Slope of my asymptote. In this case, my rise is A. My run is B. Forgot my squared here. Here, my slope of my asymptote is my rise, this dimension, is B. My run is A. I need to be able to do this exact same thing for a parabola and an ellipse. Without this relationship between my standard equation and what A, B, and C mean dimensionally in the graph, you're going to be a very unhappy person. Okay? You've got to know these relationships. You've got to know how these standard equations relate to the geometry for each one of the conic sections. If you can do what I just did without aid of reference for all three conic sections, I think you're going to be good, very good to go tomorrow. Okay, in the next couple of videos, I'm going to show some specific examples of each one.